Kuzu Zampola. A very warm welcome to Bhutan e-learning project. My name is Samten Wangchuk. I'm currently working in Gaselo Higher Secondary School under Wangdi Phorang Zongkakla. Today, I'm going to present a lesson on the topic compound and multiple angles. It's intended for Key Stage 5, classes 11 and 12. The overall lesson overview: number 1, radian as a unit of measuring angles. 2, magnitude of angles. 3, trigonometric ratios and relationship. Trigonometrical ratios of allied angles, compound and multiple angles, and solving related questions. Let me tell you what is a radian. A radian is the measure of the central angle subtended by an arc equal in length to the radius of the circle. Now, we have a circle with the center O and radius R. So radian is the measure of the central angle subtended by an arc. That arc, this arc, is equal to the length of the radius. Let us name it as A and B. And if we join this, this is also R. And the angle that is formed here is 1 radian. So the SI unit of radian is rad, R-A-D, rad. Now, let us go to the relationship between degree and radian. We will use this diagram only. Now, the ratio between the arc AB to the circumference is equal to 1 radian divided by circumference is, what is the angle of around the central angle? 360 degrees. So what is the length of arc AB? R. R divided by, what is the length of the circle? Circumference. That is equal to 2 pi r, which is equal to 1 radian divided by 360 degree, which is equal to 1 radian divided by, I can write 360 degree as 2 times 180 degree. Now, if you compare these two, 2 and 2, r and r get cancelled, and you have left with 1 divided by pi is equal to 1 radian divided by 180 degree. So, if you cross multiply, 1 radian into pi can be written as pi radian, which is equal to 180 degree. Let us go to the magnitude of an angle. Now, let's divide the axis into 4 quadrants. We have the first quadrant. The axis can divide into 4 quadrants. The first quadrant, the angle, that is, the magnitude of the angle is different for different quadrant. The angles that falls in the first quadrant is between 0 degree to 90 degree. And we also learned the angle can be measured in radian. So in radian, it can be 0 degree to between pi divided by 2. So 90 degree is equal to pi divided by 2. So these are the angles that measures in the first quadrant. In the second quadrant, the angle, the magnitude of angle is between 90 degree to 180 degree. In radian, it will be pi divided by 2 theta. So 180 is equal to pi. In the third quadrant, magnitude of angle lies between 180 degree and 270 degree. And in radian, it should be pi between pi and 3 pi divided by 2. And in the fourth quadrant, the angle measures between 270 degree and 360 degree. In radian, it should be 3 pi divided by 2, and 360 is 2 pi. These are the magnitude of the angles. The measures of angles can be more than 360 degree depending on the number of rotations. For one rotation, the angle is 360 degree. for 2 rotations, it is 2 times 360 degree. And for 3 rotations, it is 3 times 360 degree, and so on. Now let us look onto this picture to check 415 degree in this diagram. So 415 degree is equal to 1 rotation, that is equal to 360 degree, times 1 plus 55 degree, which will be equal to 415 degree. So this 415 degree angle is more than 360 degree, and 415 degree lies in the first quadrant. Now similarly, let us look on the next diagram. What about the angle 1480 degree here? So 1480 degree, how many rotations are there? If you count, you can see there are 4 rotations. So that's why it is 360 degree times 4 plus 40 will give 1480 degree. Again, this 1480 degree is greater than 360 degree, and it lies in the first quadrant. Now, with this, you can find out in which quadrant this following angles lies. We have 132 degree, 615 degree, and in the form of radian, it is 5 pi divided by 2. And finally, I have given you minus 400 degree. So what does this minus sign mean? Okay, so far you have learned that angle is measured in counterclockwise direction, and if the angle is measured in other direction, that is clockwise direction, then angle is measured in negative. Now let's recall on trigonometric ratios. You learned this one in class 10. It's just a recall. Now, if you look at the diagram, it is a right angle triangle. It has a base OM and perpendicular height PM, and its hypotenuse OP. And it makes an angle, let us say angle MOP is angle A. With reference to angle A, the side Y will be perpendicular height, and X will be the base. Now, from here, you can get 6 different trigonometric ratios. Sin A means MP divided by OP, which is Y divided by R. This is sine of the angle A. Similarly, cos is base divided by hypotenuse, that is X divided by R. That is the cosine of angle A. And tangent of the angle is perpendicular divided by base, Y divided by X. And the reciprocal of the first 3, sin A, cos A, and tangent A, will give the next 3 trigonometric ratios. Cosec A is the reciprocal of sine function, and secant A, short we read as sec A, is the reciprocal of cosine function, and cotangent A, in short cot A, is the reciprocal of the tangent angle. Now let us go to the quotient relations. We have different types of relations amongst the 6 trigonometric ratios. Now, the ratio between the sine function, sine A and cos A, sine A to the cos A is equal to tangent A. And the second one is cotangent is the reciprocal of the tangent. So it will be automatically, we can say cos A divided by sine A. And we have another relation, that is the square of the sine function plus the square of the cosine function will be always equal to 1. And it is called square relations. And second one, we have sec square A is equal to 1 plus tan square A. And the third one is cosec square A is equal to 1 plus cot square A. And these relations are very important, and you have to use these relations in solving the problem in compound and multiple angles. So let's move on to the next one, that is trigonometric ratios of standard angles. Standard angles refers to these angles: 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And if you know this is the measure of these angles, if you know the value of these angles, then you can find out the value of other angles as well. Now, if you look at this, look at the diagram here. The diagram is again the diagram is the right angle triangle. I have given here the 45 degree as a reference angle here. 45 degree, if this is 45 degree, the angle P will be also 45 degree. And therefore, the length of PM and OM will be A and A, which means they will be equal because the angles MOP and angle OPM will be 45 degree each. So, if you're using the Pythagoras theorem, we can calculate the length of the OP, that is A times root 2. Now, deriving the value of the sine 45 degree. So sine 45 degree, if you use this, sine of this 45 degree will be A divided by, what is that? Perpendicular height is PM, A divided by hypotenuse, which will be A divided by root 2. So AA get cancelled, and you will be getting 1 by root 2. So similarly, if you can calculate for other standard angles of other trigonometric ratios, this is the final table of values for the 3 trigonometric ratios. Sine 0 degree is 0, sine 30 is half, sine 45 is 1 divided by root 2, then sine 60 degree is root 3 divided by 2, and sine 90 is 1. And cosine function is just cos of 0 is 1, 30 is root 3 by 2, 45 is 1 divided by root 2, then cos 60 is half, then cos 90 is 0. And tangent of 0 is 0, tangent of 30 degree is 1 over root 3, then tangent 45 is 1, tangent 60 is the root 3, and tangent of 90 degree is undefined. We call it as undefined. We will not get the value of this function. So these are the values of the 6 trigonometric ratios, and using this table, you can find out the trigonometric values of other 3 ratios, that is cosecant, then secant, and cotangent. The value of these 3 will be easily found out. I'll just give you one example. Suppose sine 45 degree is 1 divided by root 2. Then what is the reciprocal of sine? It will be cosecant. So which will be cosec. The reciprocal of 1 divided by root 2 will be root 2. So the cosec of 45 degree will be root 2. So similarly, just reciprocal, you can do it, and then you will find out the value of that. So for you to try, I have given one question here. What is the value of the function 2 tan 30 degree divided by 1 plus tan square 30 degree? The next one is we are going to learn trigonometric ratios of allied angles. Before we move on to that one, we'll go through this diagram here. We know that in one rotation, there are 360 degree. Now, this revolving line OP, based on the position of the revolving line OP, the angles can be either positive or negative. The angle that falls in the first quadrant, all the trigonometric values will be positive. And if it falls in the second quadrant, it will be only sine will be positive, rest will be negative. And in the third quadrant, tangent will be positive, rest will be negative. And in the fourth quadrant, only cos function will be positive and rest will be negative. Now, so this allied angle, so we can see that this OP, if this revolving line, if it moves in clockwise direction, then what happens is this angle measures negative. So this negative angle, so if you find out this, the sine of this angle, sine of negative theta, then what happens is MP prime divided by OP prime, which is perpendicular by hypotenuse. So this is equivalent to negative of MP divided by OP, which will give negative sine theta. So with this negative theta falls in the fourth quadrant, the angle should be, theta should be acute angle, and if it falls in the fourth quadrant, cosine will be positive, and rest, other two will be negative. And 90 minus theta, it falls in the first quadrant, so all will be positive. And if it comes to the 90 plus theta, the angle which is up to here is 90, and 90 plus theta will fall in the second quadrant, so only sine function will be positive here. When it comes to the 180 degree minus theta, it will be also in the second quadrant, and therefore sine will be positive, others will be negative. 180 plus theta is in the third quadrant, and then tangent will be positive, rest will be negative. Then 180 plus theta will be in the fourth quadrant, and cos function will be positive, and rest will be negative. 2n pi minus theta, it means n represent the number of rotations. So if n is even, that will be 360 degree minus theta. So which means it comes in the fourth quadrant. Like that, cos will be positive. And similarly, 2n pi plus theta will be, it depends on even number of rotations and odd number of rotations. And then theta, that means it comes in the first quadrant. So with that, you can use this table to evaluate this, to find the value of this function. Find the value of cos 420 degree. So cosine of 360 plus 60, because 360 plus 60 will be 420. So that means it falls in the first quadrant. So it will be positive. So cos 60 is half. Then similarly, we can do the same equation. We can solve the same equation in different methods. Cosine of 420 degree can be 2 times 360 degree. So 360 is 2 pi, and n is 2 here. So in that case, 720 minus 300, which will be equal to cos 300. So cos 360 minus 60 will be cos 60, which will be, again, the answer will be half. So with this, for you to try, I have given one question here. That is, find the values of tan 225 degree. Identify. You have to find out in which quadrant this angle lies. Then come into second question, sine 315 degree, then tangent of negative 1742 degree. The main topic that you are supposed to know here is compound and multiple angles. If you look at this diagram, we have two angles here now. X, we have angle A and B. And compound and multiple angle refers to what will be the angle A plus B, sine of A plus B, cos of A plus B, and tan of A plus B. Do you think that I just want to throw one question to the students, whether sine A plus sine B? There is a chance of writing this one in the form of sine A plus sine B. But if you look at the diagram here, the addition formula, the angle XOY is A. Angle XOY gives A. Angle YOZ is B. That means angle XOZ will be A plus B. And we want to find out the sine of this A plus B. This is the derivation. You can see here the angle KPN is equal to, what is the shape of that KPN? Is right angle triangle. And that is equal to, the angle KPN will be 90 degree minus P and K, which means one of the angles is, it is a right angle triangle, and therefore the sum of other two triangles will be 90. So if you subtract one of this from 90, then it will be equal to angle KNO. So which means this angle KNO will be equal to angle NOM, and which will be equal to A. So that means angle KPN, KNO, and NOM will be equal to A. So sine A plus B. Now sine A plus B is LP divided by OP. Triangle OLP is the right angle triangle. So which means LP is the sum of the two sides here, length, KP and KL. So I have replaced this LP by KP plus KL divided by OP, and KP plus MN and KL are equal, because these two lines KL and MN are parallel to each other and equal in length. So which means that will be, if I break into the sum here, KP divided by OP plus MN divided by OP. So which will be sine A plus B is MN divided by ON times ON divided by OP plus KP divided by PN times PN divided by OP. So which is sine A plus B is, what is MN by ON? MN by ON is, MN divided by ON is, if you look at the triangle ONM, MN by ON is sine A, ON by OP is cos B, plus KP by PN is cos A, times PN by OP is sine B. Therefore, A plus B is a compound angle, is a multiple angle. So sine A plus B is equal to sine A cos B plus cos A sine B. We can read this one as sine A times cos B plus cos A times sine B. Similarly, similar type of derivation will be done here, and you will get cos A, for cos also, cos A plus B is cos A, cos B minus sin A, sin B. Tangent tan A plus B is equal to tan A plus tan B divided by 1 minus tan A, tan B. This is a very simple formula for compound and multiple angles under addition formula. So, in continuation to addition formula, we have another one. That is, in the addition formula, we have learned that sin A plus B is sin A cos B plus cos A sin B. So, if you replace B as negative B, then you will be getting this formula. Sin A minus B is sin A cos B. Instead of positive, now it will be negative. So, it will be sin A cos B minus sin B cos A. Then for cos, cos A minus B, cos A cos B plus sin A sin B. And tangent will be tan A minus B. So, tan A tan B divided by 1 plus tan A tan B. And then coming to the next one, double angle formula. Now, similar derivation will be done here. Now, in the same formula, sin A plus B, cos A plus B, tan A plus B, in place of B, if you substitute A, then A plus A will become 2A. So, which means we know that sin 2A is equal to 2 sin A cos A. Then, because we can replace this one with B is equal to A, and then we get the double angle formula. Why it is called double angle formula is there is twice the angle A. So, sin 2A, 2 sin A cos A. Then cos 2A can be evaluated using this three formula. Cos square A minus sin square A. Another one is 1 minus 2 sin square A. 2 cos square minus A. So, whichever is appropriate according to the question, you can use either of this. Then coming to the last one, that is tangent of 2A. Tan 2A will be 2 tan A divided by 1 minus tan square A. So, this formula, student need to just to remember this formula, and then this will be applied to solve or prove some trigonometric identities. Now, the next one is the product formula. So, here when you talk about the product formula, we have this compound angle is coming again and again. You can see sin A plus B is equal to sin A cos B plus cos A sin B. Let this be equation number 1. Let us say formula number 1. Then sin A minus B is equal to sin A cos B minus cos A sin B. Let this be formula number 2. Now we have the formula here, 2 sin A cos B is equal to sin A plus B plus sin A minus B. So in that case, in place of A plus B, you substitute C. In place of A minus B, you substitute A minus B is equal to D. Then when you substitute that, see, you can see sin C plus sin D here. Sin C plus sin D is equal to 2 sin C plus D divided by 2 times cos C minus D. And similarly, for sin C minus sin D here, we are substituting here. So you get sin C minus sin D is 2 sin C minus D times cos C plus D divided by 2. Then in this formula, if you substitute with again A plus B, A minus B with C and D, you get this formula. Then for this second one, you can substitute cos C minus cos D will be equal to 2 sin C plus D divided by 2 times sin D minus C divided by 2. We have learned double angle formula. From double angle formula, we can derive half angle formula now. Half angle formula is derived from double angle formula. We have learned that cos 2A is 2 cos square A minus 1, the formula that we have learned under double angle formula. So, keeping 2 cos square A on one side, you take negative 1 on the other side, then you get this formula, cos 2A plus 1. So, cos square A is equal to cos 2A plus 1 divided by 2, because you are dividing both sides by 2. So, which will be cos A. Square root of, why it is square, why we have taken square root is here it is a square. So, to find this cos A now, earlier it was 2A, now it has become A. So, which means A is half of 2A. So, that's why this is double angle formula. Similarly, we can derive this one from the other formula. I told you that there are 3 formula for double angle formula for cosine function. So, you can use other formula to find out the same type of formula. And here, from here, we can find out the half angle of sine function. Similarly, we have example here. Sin 30x. Sin 30x is equal to sine times 2 into 15x. 2 times 15x. Because we know that 15 times 2 is 30. So using the double angle formula, we know that sine 2a is 2 sine a cos a. So sine 2 times 15x is 2 sine 15x into cos 15x times 15x. So similarly here, 2 sine 15 degree times cos 15 degree is 2 sine 15 degree times cos 15 degree is sine 30 degree. Why it is sine 30 degree here? We know that sine 2a is 2 sine a cos a. So what is a? 15 degree. 2 times 15 is 30 degree. Sine of 30 is half. We have some more examples here. So 1 minus 2 sine square a, 2 sine square 22.5 degree, and 2 times tangent 22.5 degree divided by 1 minus tan square 22.5 degree. So solution cos 2a, we know that that is another formula that we have derived. So 1 minus 2 sine square 22.5 is a. So which means cos into 22.5 degree, which will be 2 times 22.5 will be cos 45, which will be 1 by root 2. And similarly, you substitute here, and then this is the formula for tangent 2a, double angle formula of tangent, and then when you substitute, you get tan 45 degree is equal to 1. So this is sine 15, and then this is the sine 30 degree. Sine 30 degree is, we got sine 30 degree as a double angle formula, and if it is half of sine 30, it will be, you can substitute, we have derived this formula, substitute there, because the formula for sine a is plus minus root of 1 minus cos 2a divided by 2. So which means substitute, and then we get the answer as half times root of 2 minus root 3. So triple angle formula, we have sine 3a, cos 3a, and tangent 3a. So these are the triple angle formula, and out of this three formula, I'm going to derive one of this. Let me derive sine 3a. Now, proof. Here, sine 3a. So it is a triple angle formula. 3 means triple. So triple angle formula. We can write this one as the sum of 2a plus a. Because 2a plus a will be 3a. So we know that you have learned that sine a plus b is sine a cos b plus cos a sine b. Now you take this 2a as a and a as b. So what you do is, you can substitute this one as, now what is this? Sine, what is a? 2a, cos a. We have cos 2a times sine a. So now, in that case, so we have 2 sine a. What is sine 2a? We have learned that is 2 sine a cos a times cos a plus, now we have cos 2a. You can keep this sine a outside. And then what is cos 2a? We have learned that it is 1 minus 2 sine square a. Then, coming to that, we have 2 sine a times cos square a. Cos a times cos a is cos square a plus sine a times 1 minus 2 sine square. We write as it is. And then from here we have 2 sine a, okay, 2 sine a, and what is cos square? 1 minus, we have 1 minus sine square a. We learnt this in the previous content that talks about the square relations. Then plus sine a times, okay, sine a times 1 minus 2 sine square a. If you multiply this, 2 sine a minus, this is 2 sine cube a plus sine a minus, again 2 sine cube a. Then that will be, what is 2 sine a? Sine a means 2 sine a plus 1 sine a is 3 sine a minus 2, these two are like terms. You can add them. This will be 4 sine cube A, which is equal to sine 3A. So this is the formula for the triple angle formula for the sine function. Now you can try for other two, cos 3A and tan 3A, in this manner. Let us do one question to prove that sine 3 theta divided by sine theta minus cos 3 theta divided by cos theta should be proved as 2. Now we will take the left hand side, taking LHS. So this side is LHS. Now you know the formula of sine 3 theta, that is triple angle formula of the sine function. What is the formula for that? We have 3 sine theta minus 4 sine cube theta divided by sine theta minus, what is the cos 3 theta? We have the formula 4 cos cube theta minus 3 cos theta divided by cos. So we want to prove that LHS is equal to RHS. So which means we have LHS is equal to this side. What is from these two terms, which one is common? Sine theta is common. Sine theta take outside, and then what is left inside? 3 minus 4 sine square theta divided by sine theta minus, again here the common is cos theta, then 4 cos square theta minus divided by cos. So which means we can now cancel sine theta and sine theta here. This can be cancelled. Here also you can do that. So what is left on the top? We have 3 minus 4 sine square theta, 3 minus 4 sine square theta, then minus, we have minus here. We have to be very careful here. So open the bracket here, and then we have left with 4 cos square theta minus 3. Okay? Then now LHS is equal to 3 minus 4 sine square theta, and multiply each term inside the bracket by the negative 1. So which will be minus 4 cos square theta plus 3 here. Because negative 1 times negative 3 is positive 3. So which will give as LHS is equal to, now 3 plus 3 we have 6 minus, now what is common again? 4 is common from these two. So 4, then we have taken out negative 4 outside, so inside it will be sine square theta plus cos square theta. So which will be LHS is equal to 6 minus 4. What is the, according to square relation, sine square theta plus cos square theta is equal to 1. So 4 times 1, which is LHS is equal to 6 minus 4, which is equal to 2. Therefore, we prove that it is equal to RHS. Now, here, this is just a simple example. We will go to the questions here. Find the values of sine 2 theta, cos 2 theta, and tan 2 theta, given that sine theta is 3 divided by 5, theta in quadrant 1. So you need to be very careful when this restriction is given, theta in quadrant 1. We have learned that the sign of the values. Now, the solution here is, now we can find out cos theta here. Cos theta is root of 1 minus sine square theta, because you know that sine square theta plus cos square theta is 1. So root of cos theta will be this one. We have directly substitute sine theta, because the value of sine theta is given as 3/5. So we have substituted here, and then this is 25 minus 9 divided by 25. So under the root, and finally you are getting 4 divided by 5. So this is the value of cos theta, and tan theta will be sine theta by cos theta, and if you divide these two, then you are getting 3/4. So now you got the value of sine theta is already given, cos theta is 4/5, tan theta is 3/5. So 3/4. Before you find this value of sine 2 theta, you need to find out cos theta and tan theta using this one. So finally, you got this sine 2 theta is equal to 2 sine theta cos theta. So we substitute sine theta and cos theta here, and then we got the answer as 24 divided by 25. So that means the value of sine 2 theta will be 24 divided by 25. You can also do this in a similarly, you can do it for find the value of cos 2 theta and tan 2 theta by substituting the double angle formula using the same value that we have got earlier, and then do the same thing, and then you'll get the answer in this manner. You can try yourself. Now we have finally I have a question for you students after having learned this many topics. So please ensure that you do this question. The first question is compute tangent of 105 degree using any two standard angles. Then show that cos 15 degree minus sin 15 degree is equal to 1 divided by root 2. Question number 3 is derive the formula for following using functions of 2 theta and then of theta. Sin 4 theta, cos 4 theta. You need to derive we have derived the formula for triple angle formula. Now you can extend your understanding of the compound angle formula to derive this formula for this trigonometry function. Then number 4 is express cos 6 alpha in terms of cos 3 alpha. Then 5 is determine the value of sin alpha plus beta, cos alpha plus beta, tan alpha plus beta when sin alpha is 3 out of 5, 3 over 5, cos beta is 5 over 13. So these are the 5 questions for you students. Please do these questions, and then after having completed this question, able to recollect all the lesson that you have learned. Thank you all for attending my lesson. See you in the next lesson.